Want to see Iowa on a good day? Why don't you take a look at this? Something tells me you're no longer going to be in Des Moines, Toto. Look at that. That's insane. I've seen those things up close. Well, not too close, of course, because those things are dangerous. When I see those things running, or when I see those things coming, I start running, because that's called common sense, unless, of course, you're a storm chaser. Ever wonder how it's predicted? Bad weather? Well, Suzanne Anderson, a lead forecaster for the National Weather Service, is here, right here. Look at that's her. That's Suzanne. And she's going to explain the technology involved with weather forecasting. Suzanne, welcome to Call for Help.
Thank you. Thanks for having me.
Yeah. So we've got this weather thing. Everybody's got weather. How is technology making it easier to forecast?
Well, we've got all kinds of technology that we use to forecast the weather. Importantly, it starts with what's going on now. How do we know what's happening now in the world of weather? One of our tools is satellite that you can see right here, and this way we can monitor where the clouds are and where it's raining, stuff like that. We've got Doppler radar, which also helps us,
What is this particular image telling you right now?
Right now, it's showing some high cloudiness over Arizona and over the Four Corners area, as well as some cloudiness coming into California and Oregon.
Okay, and it's just looping back and forth.
It's just looping back and forth, and this should be real time or close to it.
Okay, and that's one type of satellite imaging that you guys used to help predict. Here's another type, and it looks like it's measuring velocity.
Well, actually, what this is what we would call a computer model, which are complex programs that take the atmospheric conditions out in time. It starts with what's happening now and then takes it out in time, up to 10 days in the future. So we use this to, along with what's happening now, to forecast the weather. We look at these lines and they tell us, okay, there'll be a storm coming or not.
Now, you said it'll tell you about 10 days in advance. Is there a certain law of diminishing returns in terms of accuracy in predictions? How many days out can you really go?
Well, up to about 5 days really well. It can sometimes get, if something isn't starting out, if it's not initialized well, the conditions put into the computer programs, you can end up with all kinds of nonsense at the end.
So the shorter the better.
Exactly.
Don't be impressed with those stations that say we have a 6-month forecast, folks. You don't want that. 5 days.
5 days good, yeah.
Okay, we've got a little animation on the screen. I was wondering, is this explaining some type of technology?
That is sort of a little thing explaining the Doppler radar, or at least the radar, how it works. The radar itself sends out a pulse of energy that hits some object, a raindrop per se, or something, and which the energy bounces back to the radar, and this signal, it looks at like the movement of, say, a storm or whatnot. All this information gets fed into more computers that we have that can see things like rotation in a storm, like would be, you would see in a tornado. And
yes, the hook echo. And
right.
I'm very familiar with those terms. I'm telling you, man, Iowa's horrible with tornadoes in the summer. What exactly is Doppler? I mean, we're talking, this is Doppler, but what is it?
Doppler, it's named after a physicist, Christian Doppler, and it's actually a change in phase. Like you've heard that the train going by and the whistle changes in pitch as it gets further. That's the change, a shift in phase of the energy. So Doppler, it can measure motion as opposed to just plain, if there's a storm there, it can see the motion, the rotation in the storm, or the winds.
It's kind of like getting a stronger prescription or something that gives you a clearer picture.
Right.
Okay. What about using computers, just in general, other than specialized technology equipment? What about just regular old computers?
Well, everything we do is on computers. Like I said, the Doppler is computers. We've got two big mainframe computers back in D.C. that crunch all the numbers for the computer modules.
It's okay. We like geeky stuff here.
Right.
We've got something actually on the screen right now, and this is something that people could get this stuff at home, correct?
Oh, right. This is not happening now, which is good, because this was a tornado that hit Oklahoma City back in 1999. This is the radar image of it.
And I see the hook echo, and the hook echo's at the bottom.
That's a very good
little thing right there.
Very good, Chris. Yeah.
Yeah.
You passed.
All right. I was considering being a weather person. I just couldn't.
Well, you would fit right in our world.
Really?
Yes.
Is it the hair?
The glasses.
Oh, the glasses. Of course, what was I thinking? So how would you suggest people, other than tuning in and watching television or listening to the radio, how could they check the weather at home on the internet?
Well, there's millions of different websites that you can look at for. Well, this is actually another way to look at the radar images.
Oh, really?
We can go back to radar. This is a current composite of all the radar echoes across the country from our Doppler radar network.
Any links I want to look at here?
Go ahead and click on where these blue.
Ooh, because there's something happening.
There's something happening there. So this will take you to New York City, and you can see there's a little rain off the coast. So but this is current. So a nice real-time image of radar. So you can look at that national map and click on your home state or area. Like if you wanted to look at Iowa, you could see if anything's happening there.
And this is using that Doppler technology.
This is all our Doppler radar, yes.
Very, very accurate.
Yes.
Very.
Oh, yeah.
Always. And always up to date.
You bet.
Here's another type of page, I guess, that we're pulling up. It looks like a different type of map.
This is all the National Weather Service offices around the country. And to get a forecast, you could click on any of these dots closest to your hometown, like there's the Des Moines, Iowa web page. The Weather Service is in the process of all having a similar page for every office, a similar look and feel. We've started in the West. We've started changing our pages over, and pretty soon the whole country will be this way.
Oh, wow.
But if you go back to that other link.
This one?
Back one more.
Ooh, this one.
No.
This one.
This one.
This one.
Yeah.
Okay.
No. Oops. Where did it go? Well, just go back. Hit the back button.
Okay.
Should.
This one.
Yeah. There you
right.
go. Okay. Scroll back up to the top.
Up to the top.
Up here in the search window, you can either type a city name with a state.
California.
Except for spell it right.
Oh, did I not? Oh, Cisco. I always get that X in there.
I know. It's hard to get that right.
It's silent, folks.
And
oh,
there we go. There's a nice,
clean.
Should give you a 7-day forecast if you read the text there, and also tell you what kind of warning is in effect. We have a heavy surf advisory in effect.
Ooh, Patrick would love that. Like surfing.
That's right. So any zip code will work. So that's a real quick and easy way to get a forecast.
A lot of good stuff. And of course, keeping us in touch with all that severe weather is very important. We appreciate all the work you guys do over there. Thank you, Suzanne,
Thank you
for coming in. And of course, if you want to learn more about the technology used to forecast your weather, check out Suzanne's article on our website. The address, of course, is at techtv.com/call for help.